Okay, we arrive at the end of this chapter, and we arrive into, I suppose, again, familiar territory, that the final part of this chapter is going to involve, again, going back on something that we've done in algebra before, and that is questions involving three variables. Okay, now in this case here, because it's a circle, we're dealing with G and F and C. And the reason why we're dealing with G and F and C is because in the questions we're about to do, the only formula that you have to worry about is what we call the general formula of the equation of the circle, okay? Which is, of course, x squared plus y squared plus 2gx plus 2fy plus c is equal to 0. So that's the general formula, or general equation, I suppose, probably a better way to put it, okay? And that is all you're going to be using right the way through these questions here. Now, in using that, as you can see down here from the bottom paragraph of this slide, minus g and minus f will be the center of that circle. So even if they don't give you the numerical center of the circle, you are going to take minus g minus f as being the center of every circle, okay? So if we know nothing about a circle and somebody says find its equation, done. X squared plus y squared plus 2gx plus 2fy plus c equals 0. What's its center? Minus g minus f. What's its radius? The square root of g squared plus f squared minus c. These are the only things you have to use going into the next section, all right? And I do want to preempt this by saying these questions are extremely important. These are the questions that are always examined, whether it be in your Leaving Cert, whether it be in your summer exam, whether it be in November exam. These are the questions that are always examined. So I would advise you to give 120% concentration to the next half an hour or so, and then involve yourself with the questions that are asked at the end, and make sure that you understand how to build equations in G and F and C. The final thing I'll say before we move into some examples is that if you're working with F and G and C, that's three variables. Now go back to what we talked about when we were dealing with these in the first three chapters of book 1. When you have three variables and you wish to solve them, the only way that you can do that is by making sure that you have three equations in those variables. That's it, three equations in those variables. So therefore we are looking for, in all of these questions, three equations in G, in F, and in C, or in any derivative of those three. Okay, but that's the key thing I want you to keep your head moving in here. If we're working with G and F and C, then our job in all of the questions you're about to see is to build three equations in those variables, and they will always give you the correct amount of information to be able to build three equations. And then we fall back on our knowledge of algebra, because all we've got to do then is to remember, how do we solve three equations in three variables? And the answer is by reducing them algebraically down to one equation in one variable, because that's the only way you can solve an algebra. So we've got to get rid of two variables along the way. So what we do is we take three equations and three variables, reduce them down to two equations and two variables, and then take those and merge them down to one equation in one variable, solve. And then by substitution backwards, we can work out the other two variables and their values. Okay, enough talk, let's move on. Just need to put this in here. Maybe remote control. If I don't put that in, I'm in trouble. Can't turn the slides. Okay, so before we just move into an example, one final thing I want to talk about is this. What happens if the x and the y axis are a tangent to the circle? So if somebody used to say to you that the x-axis is a tangent to a circle, or the y-axis is a tangent to a circle, is there any hidden algebraic information in there? And the answer is yes, there is. I'm going to show you why. If you take the circle as being x squared plus y squared plus 2gx plus 2fy plus c equals 0, which is the general equation of the circle, then the center of every circle is basically minus g minus f, okay? It's half the x coordinate with its sign changed, half the y coordinate with its sign changed. So it's minus g minus f. Now, I'm going to take two situations here where the x-axis and the y-axis are tangents, because something very unusual happens. If, let's take the x-axis first of all. If the x-axis is a tangent to the circle, well then the length of the radius will simply be the same as the height the center is above the x-axis, which happens to be the size of y, meaning that minus f will be the radius. See that? Now it doesn't really matter where it's plus f minus f, and I'll explain why in a moment. If the y-axis is a tangent, well then the center of the circle will be g units away from the y-axis. So this one here will be minus g, will be equal to the radius. So when I'm talking about minus g minus f, I'm talking about if your center is minus g minus f, and if the x-axis happens to be a tangent, then your center will be f units away from x. If your center is minus g minus f, and your circle has the y-axis as a tangent, well then you will be g units away. Your center, I should say, will be g units away from the y-axis. Now, if that's the case, let's just take both of these. Let's take the fact that minus g, or g in this case, because distance, I suppose, can't be negative, so that's why we say g here. So plus g and plus f. So g equals the radius. Whenever the y-axis is a tangent. Okay, now, let's just take a look and see what happens. If g is the radius, then we can replace g, or the word radius, I should say, with the formula for a radius. And when it's a general form of the equation, it's g squared plus f squared minus c. Next step, clear the square. Square both sides. That's to clear the square root. Cancel the g squareds, and what do you notice? You notice that 0 is equal to f squared minus c, which means c is equal to f squared. Now that's an extremely useful deduction. All right, so when the y-axis is a tangent, what do we notice? We notice that c is equal to f squared. Okay, now what about the x-axis? Well, let's do the same thing again. Let's just take all of that off there, and let's do the same thing, but this time for the x-axis. I'll make the x-axis a tangent. Okay, so if the x-axis is a tangent, then f is going to be the radius. So f is equal to the radius if the x-axis is a tangent. Okay, now replace the word radius with the appropriate formula. And because we know nothing about this circle, the appropriate formula is the square root of g squared plus f squared minus c. So in that case, f is equal to g squared plus f squared minus c. Square both sides. F squared equals g squared plus f squared minus c. Cancel the f squareds on both sides. 0 equals g squared minus c, which means c is equal to g squared. So therefore, if the x-axis is a tangent, well then c is equal to g squared. And those two deductions are extremely important if the question should ever mention to you that the x-axis or the y-axis is a tangent. If the y-axis is a tangent, c equals f squared. If the x-axis is a tangent, c equals g squared. So just keep in mind, whatever axis is the tangent, you take the letter that represents that particular axis and you square it. So for example, if the x-axis is a tangent, well then what's the x value of the center? Minus g, square it, g squared. So if the x-axis is a tangent, c equals g squared. If the y-axis is a tangent, c equals f squared. So in fact, you don't have to know how to derive these things, but you do have to remember the relationship. If the x-axis is a tangent, c equals g squared. If the y-axis is a tangent, c equals f squared. And both of those are extremely important when it comes to using the information we're given to build equations in 3 variables. So just thought I'd do that with you before I move into the questions themselves. Now, let's hit the questions. Well, before that, as we said already, if the x-axis tangent g squared equals c, or c equals g squared, and if the y-axis is, well then c equals f squared. We know that, and remember that, that's extremely important. Okay, so I'm going to do 3 examples, and the reason why I'm doing 3 examples is because these questions are important, very important, moving in to the final lap and your summer exams. Okay, so if you're going to really focus on anything, focus very much on these and how to build your equations. So find the equation of the circle that contains the 2 points Q and P and whose centre is on the line x plus 5y equals 15. What do we know about the circle? Nothing. Find the equation of the circle. Well, I know what the equation of the circle is, because in this case, because we're not told the length of the radius, because we're not told what the centre is numerically, that means I know nothing. There's only 2 things I can know about a circle: its centre and the length of its radius. Neither of them are given. So in that case, you have to use the general form of the equation. You have no choice. And in fact, all of these, you're going to be using the general form of the equation. Okay, what is it? It's x squared plus y squared plus 2gx plus 2fy plus c is equal to 0. Now, what about the circle? Well, we don't know anything. We don't know its center, we know its radius, but we do know some information about what's happening on the circle, and that is that we've got 2 points. We've got Q and we've got P, and they are on the circle. The circle contains those 2 points. Now go back to when we were dealing with points in, on, or outside the circle. If points are on the circumference, then the left side and the right side of the equation here have to be the same. So what I'm going to do is this. I'm going to look and see what happens at Q, which is 0, 2. And then I'm going to take a look and see what happens at 1, 5. So in other words, because the circle contains the points, we can confidently put the points into the general form of the equation. And let's see what happens. If I put in 0, 2, I'm going to put 0 in for x and 2 in for y. So 0 squared is 0. 2 squared is 4. There is no x, so that's gone. You're putting 2 in for y, so that becomes 4f. And then plus c is equal to 0. Look at what I have. I've got an equation in f and in c. And what is the equation? The equation is 4f plus c equals minus 4. So I've just moved it around to keep the variables on the left hand side and the constants on the right. The zeros are gone for a start. You don't have to worry about them. But you bring the plus 4 over the equal sign to become minus 4. And there's one equation in f and c. Now remember, yes, we're working with g, f and c, but sometimes the equations might come out with just 2 variables. All right, if that's the case, then it doesn't matter. Use it. It's going to make life easier for us. Now let's put in the point 1, 5 and see what happens. 1 goes in for x, so that becomes 1 squared is 1, 5 squared is 25, 2g, put 5 in there for y, that gives me 10f, plus c is equal to 0. And when I rearrange that, I get 2g plus 10f plus c is equal to, well, 1 and 25 is 26, bring it over to the right hand side, minus 26. There's equation number 2. And what the aim here is? The aim is to build 3 equations. That's the aim in every one of these questions. Now, where's my third question going to come from? Well, I know nothing else about the circle, but I do know that the center of the circle is on the line x plus y equals 15. So in other words, the center, now we don't know what the center is, so we use minus g minus f, is on the line x plus 5y equals 15. And if the center is on the line, well, then we do the same thing as what we did for the points that are on the circle. We put minus g and minus f in for x and y to build the third and final equation. And here's what we're going to get. Minus g goes in for x, so it gives me minus g, minus f goes in for y, so that's minus 5f is equal to 15. And guess what? There's my third equation. So now I have exactly what I set out to do. I've got 3 equations. And now all I have to do is to try and get these 3 to condense down to 1 equation in 1 variable. So let's take a look and see, first of all, where's the overlap? What do these have in common? Notice that 2 of the equations only have 2 variables. Okay, the first one has f and c, the third one has g and f, but the middle one has g, f and c. What's the only term that is present in all 3? The only common term is f. F is present in the first one, f is present in the second one, f is present in the third one. So therefore what we have to do is we have to get this equation here in terms of f and this one in terms of f, so that I can substitute that result into the middle one. Watch what I mean by that. Take this one here. We get 4f, where are we? C equals minus 4 minus 4f. Okay, so c in terms of f. Now this one here is going to give me g in terms of f, which means minus g is equal to 15 plus 5f. And that means that g is equal to minus 15 minus 5f. So now what do I have? If f is the link between all 3 equations, then f has to be your focus. So you have to find out what everything else is in terms of f. So c in terms of f is 4 minus 4f. from this equation. G in terms of f is equal to minus 15 minus 5f. So if I now take the second equation, 2g plus 10f plus c equals minus 26. What can I do? Well, the first thing I can do is I can turn g into minus 15 minus 5f. So 2 times minus 15 minus 5f plus 10f, that's fine, leave that alone, plus c, which up here I'm told is minus 4 minus 4f, and that's equal to minus 26. Now tidy this thing up. Notice it's all in one variable. Now we can solve it. So we get minus 30 minus 10f plus 10f minus 4 minus 4f equals minus 26. Okay, minus 10f and plus 10f will cancel. We get minus 30 minus 4, which is minus 34. So that will give me minus 4f equals minus 26 plus 34. What does that give me? Minus 26 plus 34. Minus 4f is equal to, well, minus 26 plus 34 is the same as 34 minus 26, which is 8, if I remember correctly. So 34, I'm not going to take any chances of making a mistake. 26 equals 8. I was right. So it's 8, which means f is therefore minus 2. And now that I have discovered f, by substitution into previous equations, I can discover g and I can discover c. Let's go back up here. There's how we find g, and there's how we find c. So if f is minus 2, what does that mean? You bring minus 2 up here. That means g is equal to minus 15 minus 5 times the value of f, which is minus 2. So g is equal to minus 15 plus 10, which is minus 5. And lastly, up here, if c is equal to minus 4 minus 4f, and we put minus 2 in here, that's going to be minus 4 times minus 2. Let me just take that out there. Make a bit of space. So we're putting up here, we're taking the value of minus 2 into this equation up here. It becomes minus 4 times minus 2. So c is equal to minus 4 plus 8. And that gives me c is equal to 4. So there's f, there's g, and there's c. Now we're not finished, because what does the question say? Find the equation of the circle. So we go back to the general form of the equation here, and we fill in g, f, and c. So now that you've found them, you're now going to go back to this equation here, which is the general form of the equation, and you're going to substitute your g and your f and your c. And here's what we get. X squared plus y squared plus 2gx, that's minus 10x, plus 2f, that's minus 4y, plus c, which is plus 4, is equal to 0. And that is the equation of the circle that you're looking for. Notice it's all algebra and coordinate geometry of the line. What did we do with the points that were on the circle? We put them into the general form of the circle. What did we get when we did that? Equations in f, g, and c. What did we do with the point that was on the line? We put the point into the line. What did we end up with? An equation in g and in f. So because you had built your 3 equations in g, f, and c, you go back to the algebraic methods of using simultaneous equations in 3 variables to solve for f, g, and c, and then you bring the values of f, g, and c back to the general form of the circle equation, plug them in, and build the equation of the circle. Okay, let's take two more examples. Let's take this one now. Now for each step, I'm going to increase the complexity slightly. Okay, just a little twist that we could have on this question. Find the equations of the circles. Now, Meet, you're going to say that again. Find the equations. It's plural. So that means there are 2 or more circles involved here. Okay, which means there could be 2 answers for G, 2 answers for F, 2 answers for C. Now, if that's the case, what type of equation always gives 2 answers? The answer is a quadratic. So all of a sudden in my head, I'm beginning to realize I'm going to have to build up a quadratic equation here in G or F or C and get 2 values, and hence get the corresponding 2 values for the other variables. Okay, so let's do that as we move along. Find the equations of the circles that contain the point 4, 3 and have centers on the line 3x minus 2y equals 0 and touch the y-axis. Okay, firstly, do I know the center of this circle? In numerical terms? No. Do I know the length of its radius? No. So therefore, because I know nothing about these circles, I talk in terms of the general equation. And the general equation, as you know, or should know, x squared plus y squared plus 2gx plus 2fy plus c is equal to 0. That's the general form of the equation. Now, what do we know about the circle? Well, we know that the circle contains the point 4, 3. So at the point 4, 3, if the circle contains the point 4, 3, then I put the point 4, 3 into the general formula for x and for y. And let's see what happens. 4 squared is 16. 3 squared is 9. 2 times 4 is 8. So that's 8g. 3 times 2 is 6. That's 6f plus c is equal to 0. And all of a sudden, I've got my first equation in f, in g, and in c. And this becomes 8g plus 6f plus c is equal to, now 16 and 9 is 25, but bring that constant over to the right hand side, minus 25. So there's equation 1. And I'm sure we'll come back to use that again in a few minutes. Okay, equation 1. Now, where's the other two equations going to come from? Well, let's move on. They have their centers. Well, what's the center of the general form of an equation? It's not a numerical center, it's minus g minus f. So the center, which is minus g minus f of these particular circles, is on 3x minus 2y is equal to 0. So what does that mean? If that center is on that line, then I can substitute minus g and minus f for x and for y to give me minus 3g plus 2f is equal to 0. So there's equation number 2. Okay? And g and f. So again, minus g goes in here, that gives me minus 3g. Minus f goes in here, that becomes plus 2f, because the signs change, is equal to 0. And where's the last one? Ah, they touch the y-axis. Now we had this already in the previous slide, or 2 slides back. If a circle touches the y-axis, then c equals f squared. Okay, you've got to remember that. That's the little hint about how to use the axes in all of this. So circles touch the y-axis. And if they touch the y-axis, another way to say that is that the y-axis is a tangent to these particular circles. And if that's the case, then what do we know? Well, if the y-axis is a tangent, c equals f squared. And we had that in the previous slides earlier on. If the x-axis was a tangent, then c would be equal to g squared. But if the y-axis is a tangent, then c is equal to f squared. So what have I got? Again, I've got equation 1, 2, and 3. What's common again to all of these? Again, what's common is f is present in all 3. F is present in the first one, f is present in the second one, f is present in the third one. Okay, so what I now have to do is get g. I have c in terms of f, so I'm now going to get g in terms of f. So let's just go back up here and manipulate this. Minus 3g is equal to minus 2f, which means g must be equal to 2 over 3f. So there's g in terms of f, there's c in terms of f. So up here, all I've got to do is take both of these, back up to this equation here, and put them in, and let's see what happens. Okay, so we get 8g. Well, what's g? It's 8 times, actually, let me just, I'm going to try and save some space here because this is a long question. So let's just stay underneath this. 8 times g becomes 8 times 2 over 3f plus 6f, keep that, plus c, which is f squared. Ah, look, there's my quadratic equation that I kind of assumed in the beginning would appear somewhere. Now I have it. So all I've got to do now is develop my quadratic and solve it. Okay. First thing I do notice is that we're dealing with thirds. As I've explained to you continuously in maths, clear all fractions when it's safe to do so. So I'm going to multiply everything across here by 3. That will give me 16f plus 18f plus 3f squared equals minus 75. See that? So again, we're multiplying across by 3, so that lock out that 3 there, giving you 8 2 16. 3 6s are 18. like that. And then 3f squared equals 3 times minus 25, which is minus 75. So all I've got to do now, 16 and 18, well, that's going to be 34. So 34f plus 3f squared plus 75 equals 0. Now, why did I bring the 75 back over to the left-hand side? The answer is because if I want to solve a quadratic equation, it has to be equal to 0. So 3f squared plus 34f plus 75 is equal to 0. And I'm going to check and see, before I run to minus b, are there any formulas for this thing? Well, we've got 3f and f, okay, or any factors I should say. 25 times 3, so 25 3s are 75. Let me just see, and that's going to work out nicely, because 3 3s are 9, and 25 and 9 is 34. So both of them are positive. So what do I end up with? F equals minus 25 over 3, or f is equal to minus 3. So I have discovered two values of f. And the job now is to carry those values of f back into these ones here. So I've got to get the corresponding values of g and c for this, and the corresponding values of g and c for this one. So let's say g equals and c equals, and the same here. Okay. So let's take minus 25 over 3 back into g. Well, where's that? It's here. See it? There's how you get g. So I'm going to take minus 25 over 3 back up here, which is going to give me minus 50 over 9. Because minus 25 times 2 is minus 50, multiply the tops, and then 3 3s are 9. And then I'm going to take this one over here, and I'm going to get 25 squared, 625 I think. 5 times 25, 625, yeah. And this one here, I get 625 over, and I'm squaring it, so that's going to be 9. Okay, this one, quite straightforward. Bring the minus 3 back over here. Mine's just going to give me minus 2. And then bring the minus 3 in here. That's going to give me 9. So, what are the equations? Well, circle 1. It'll be x squared plus y squared plus 2gx. Well, that's going to give me 100 over 9x. That's okay. Plus 2fy, which is going to be minus 50 over 3y, plus c, which is plus 625 over 9 equals 0. Now, if you want to, go and multiply the whole thing across by 9. So you get 9x squared plus 9y squared minus 100x minus 150y, because you're multiplying by 9, 3 goes in 3 times, so minus 150y plus 625 is equal to 0. That's circle number 1. Circle number 2 is an awful lot easier. X squared plus y squared plus 2gx, which is going to give you minus 2x, sorry, minus 4x, because it's minus 2g. So you're bringing a minus 2 up there, 2 2s, it's minus 4x. Then you're bringing minus 3, so minus 6y, and then plus 9 is equal to 0. So there's circle number 1, and there's circle number 2. All based on the quadratic equation that fell out when I used my 3 formulas in f, in g, and c. Okay, one more, and then I'm going to give you some to do yourselves.